So welcome all of you. This is only the fifth session, problem solving session of the course Structure, Stereochemistry and Reactivity of Organic Compounds and Intermediate, a problem solving approach. I am Vijay Rahane, Prime Minister Research Fellow at IIT Delhi and University of Queensland Joint PhD program. So this course is taught by Professor Amit Basak from IIT Kharagpur on Swayam or NPTEL platform. So today we'll cover some problems based on the topics covered in the fifth week of this course. So here is the first problem. The first problem is the maximum number of regio isomeric product that are possible to obtain from the following Paschen-Khand reaction. So they have given some substrate, one alkene, alkyne, carbon monoxide, and one alkene. In presence of cobalt to CO8 catalyst, we know these are the Paschen-Khand is the multi-component reaction, and it involves the use of the cobalt metal complex as a catalyst. And in this reaction, there are many possible products that can be formed. It depends upon the structure of these alkynes as well as the alkenes. So what are the possible isomeric products that possible for this reaction? So we'll go through first the mechanism. So in the mechanism, if you see the mechanism, the cobalt CO complex, which is a 18 electron complex, when it reacted with the alkyne, so with the loss of twice to CO molecule, it formed a complex like this. So this alkyne, so this alkyne approaches to the cobalt complex, right? Cobalt, and it form a complex in which, if you see this carbon, it coordinated with this cobalt atom. Similarly, the same cobalt coordinate with the another carbon as well of this alkyne. Along with this, the carbonyl also coordinate with the this is the possible 18 electron complex which is getting formed in this first step. So similarly, what are the different possibility here? This one is the possibility since this both cobalt are equivalent. So we'll write here Ln. Ln correspond to the CO ligands, which is in surrounding of this cobalt complex, like Ln CO3, this, right? So this one is the possibility in this step. What is the another possibility? The another possibility is the H belongs to this side. So it will form a complex like this. But if you see in this structure, so in this one, since this both cobalt are cobalt metal centers are the same, so the both possibility give rise to a similar product. So in this step, there are no different possibilities are getting formed. So in the next step, what happens? This uh, form a complex, which then react with the then loses the one CO, right? So loss of one CO atom, CO ligand, give rise to the formation of a complex in which the one cobalt have the three carbonyl carbon and one have the carbonyl groups and another cobalt have the two carbonyl group. So this will form the form complex. It's 16 electron complex because one CO atom, CO ligands getting loss in this step. So 18 electron complex converted to 16 electron complex, and then in this step, the alkyne which is getting react with this form 16 electron complex. So firstly, it will coordinate with the cobalt center to which the only two carbonyl ligands are attached. So it get coordinated with this complex. Again, the form complex will be the 18 electron complex, and then next step is the carbonyl insertion reaction, right? So this carbonyl and carbonyl as well as this carbonyl get inserted between the alkyne. So here we can see the this center and this cobalt and this carbon are getting attached here. This is newly formed bond, right, between this center and the carbonyl, which is attached to this cobalt center. So here we can see here uh, carbonyl is getting attached here. So one carbonyl here get increased. So this type of intermediate is getting formed in this step. And again, after this, with another addition of another CO or carbonyl group in between this alkyne, this bond takes place, and here the carbonyl getting inserted. Right, this carbonyl was inserted in this one. So uh, here we can see with the help of this arrow. So this bond is getting fluid between this. This one is the alkyne, right? The this these bonds are belong to, and this carbon belong to the alkyne from that is starting material, and this bond is getting fluid, getting rearranged, we can say, and this cobalt and carbon bond getting fluid in this step. So the form product will be this 18 electron complex, and you can see the structure here. And again, the ligand is the metal complex is removed to form a alkyne, which shown here is structure. So in this step, we can see here while attaching this alkyne to at this center. So at this center, the alkyne this carbon can attach to another center as well, another center of this alkyne, right? So here it attack on the terminal. This while at while the attack of this alkyne carbon to this alkene, there is another possibility of attack by at the this this intermediate internal carbon. So there these two are carbons. So here is one possibility, and here another possibility. So at this carbon also attack is possible, right? So first possibility, second possibility, here both side attack can possible. So we can here will be the one possibility. So we can see in the mechanism. In short, to roughly draw the possibilities, uh, then we can see this. Suppose this one is the alkyne, and here alkene is here, and here we can say a carbonyl. So this one is the possibility in which the If we label this one 1, 2, and alkynes 1, 2 will be 1, 2. So 1, 1 bond. So 2, 2 bond is getting formed like this. So this one is the one possibility. Another possibility is the so 1, 2, and here will be 1, 2. So this is another one possibility, right? So the mechanism will be in this step also. Mechanism will be similar. So this one product is possible. Another product will be like this. In this way, two possibility because of this alkyne, right? And sorry, alkene will be like this. So here we have kept this alkyne constant. So if we change this alkyne, so these are carbon carbon attack from will be from this side. Then the so if you carbon carbon will be here, then like this also one product will be possible, and another next product will be the so the formation of bond will be like this. So at the place of this carbon in the product, there will be at the end there will be only double bond, right? And here will be a single bond, and newly formed bond will be in between this one. So these are the four possibilities. So these four products uh, are possible. We can no need to draw a complete mechanism as shown here. So we can just by uh, trying here combination different what are the different combination possible in this one. So we can able to get answer. So the correct answer will be a 4. D. The D will be a correct answer. So next problem second. Which of the following reagent can convert an aldehyde to alkyne with one additional carbon in presence of suitable base? So in presence of base, so these are the four structure or reagents they have given, and we need to predict which alkynes, sorry, which of this reagent can convert aldehyde to alkyne with one additional carbon in the presence of suitable base. So uh, if we look at the structures, so we can able to understand the this one is the example of a Schaefer Gilbert homologation reaction. So in this one, in this reaction, the base abstract this proton and it form a this species, right? So in which in this one the negative after abstraction of proton, this carbon carries the negative charge, and when it attack with the aldehyde, so this negative charge attack on the aldehyde, it form a O negative one, right? So this one is the part of aldehyde, right? And this one is the of our this reactive species. So O negative will then attack on the phosphorus. So it form a four member ring, and then successive uh, rearrangement of double bond to eliminate the species containing phosphorus OMe group, two OMe group and one double bonded oxygen as well as the O negative. So these species get eliminated, and If you see here, the aldehyde getting formed and which contain a C N bond, and this N2 is labile N2, right? So this N2 can be easily released. So this proton, so the negative charge over here, you can see here, the negative charge over here will migrate here. So this proton is shifted as a hydride minus, right? And this N2 will be released. So it form a alkyne, right? So alkyne, in this alkyne, we can see the initial aldehyde containing RC bond, right? So this part is belong from the aldehyde, and this addition, new carbon is getting attached to this form alkene. So this is how the this species convert aldehyde to alkyne containing one carbon more than the starting. The second one is the species. It's the example of O'Hara-Bateman modification. In this one, when it reacted with the sodium methoxide or potassium methoxide, sodium methoxide, it forms a it attack on this carbon. It forms O negative, and when uh, the O negative charge come back to here, it releases the ester, and this reactive species. When this reactive species reacted with this aldehyde, then it forms a when this reactive species reacted with the aldehyde, uh, it forms an intermediate, and this O negative charge, which then similarly attack on the phosphorus, and the rearrangement of the bond give rise to the species containing reactive species containing N N2 plus and carbon carrying negative charge. And similarly, as initial reaction, this negative charge form a double bond, form a triple bond here, and this hydrogen is migrate as a hydride minus to the adjacent carbon atom with the release of N2 gas. So the alkyne is getting formed. So these two species form a alkyne with one additional carbon, right? This one is the example of O'Hara-Bateman modification, and one is the Schaefer-Gilbert homologation. So in this one, can select this one, right? This one is correct one, and these two species form the uh, when these two species when reacted with the one base, here base will be a KOH, here NaOMe, right? KOH or any base we can say here. So NaOMe, then these two forms reacted with the aldehyde, it gives the RC triple bond CH. This alkyne with one additional carbon atom. So the next problem will be the example of Elshmer-Grove fragmentation, and the question given: Elshmer-Grove fragmentation involves breakage of carbon-carbon bond. The major product obtained when the following ketone is treated with the KOH. So they have given a ketone and reagent they have added here KOH. So we need to carry out the reaction and need to identify which is the correct answer for this one. So see, when this compound reacted with the KOH, so KOH what it can do, the OH it contain O negative charge, right? So the O negative charge attack on this carbon, since the carbon is more electrospecies, uh, right? So it it form a, here will be O negative, and here OH, methyl will be here, Me. This space is getting formed. See, after this one, this O negative charge, right? This O negative can go into resonance with this carbon. So this bond is this bond will be shift here, and this spaces get eliminated. So what will product? What the product here? So here will be a O, this OH, right? So this bond is getting break. So here will be a methyl, and here will be a double bond. So this one, this basis is getting formed here. Since this O negative, this abstract the proton from here. So here will be a final product will be this methyl will be here, right? This one is single bond, this one, and this C double bond O negative. Since this it will be a acid, big acid than this one. So this O, this one don't a strong acid. So this hydrogen get abstract by these species. So this one will be a product. So the correct answer will be a C. Here is the maximum I have also given. So you can see this one will be a product. Next question is identify the correct statement about A and B. So they have given aldehyde 1, 2, 3, 4, 5, 6, right? 6 carbon containing aldehyde, and the reagent given, this one is the reagent, and in terms of base. So similar reaction, similar question we have already seen in previous one, right? So we need to identify which is statement is correct one. So first, what they have given, A form a red color precipitate upon reacting with ammonic cupric chloride. So when this A form a red color precipitate upon reacting with ammonical cupric chloride solution. So this one, what will be the form? So the red color is getting formed because so this reaction we have already seen here, uh, here in the second question, I think, right? So when this when there is reagent, right? The similar reagent is here also given here. It's example of the Schaefer-Gibber homologation, right? So in this one, homologation reaction, after this reaction, this one is the base also given and phosphate also given. So once this reaction is getting completed, so this one will be a product. So it containing this containing 6 carbon atoms. So the product form contain 8 carbon atom, right? So 1, 2, 3, 4, 5, 6, 7, or 8. So this one is the product, and we know after reaction of this one with the cuprous chloride, ammonical cuprous chloride. So alkyne, terminal alkyne, we know this one is the basic reaction. When alkyne reacted with the ammonical cuprous chloride solution, it form a red colored solution. So this one is the first statement is the correct one, and structure of B is, so we'll eliminate other possibilities. A does not form red color, so this one will be a wrong one. Since this one form product will be alkyne, and we know the alkyne on reaction with the ammonical cupric chloride solution. This is qualitative analysis test for alkynes. So when alkyne reacted with ammonical cuprous chloride solution, it form a red precipitate. So here they have given not form. So this one is the wrong one. A form precipitate. So this one we can say up to here will be a correct one. Not form. So these two are eliminated. Now next what they have given, the structure of B is like this and this one. So they have given two structures, and we need to identify which one is the correct, right? So we need to carry out this further reaction N C CH2 CO2 ET. So if we carry out this reaction further, then what is getting formed? So in presence of cobalt, we'll we'll write it here. In presence of this alkyne, 1, 2, 3, 4, 5, 6, 7, 8, right? This alkyne in presence of cobalt, right? This form a cobalt complex, right here, and this cobalt complex uh, in presence of this cobalt complex, this alkyne form a bond, right? So it form an intermediate which contain this bond is getting formed right here. So this ring 1, 2, 3, 4, 5, 6. The 6-member ring is getting formed, and here there will be double bond, here will be double bond, and here cobalt. Oh, sorry, I have made a mistake. This double bond directly attached here, right? And when it created with this one, we can see uh, NCO2 ET, right? So when this when it react with this one, so this product you can see both are if you see pass a plane of symmetry, right? So both sides are identical. So we can write like this also, or we can write it the product will not get affected, right? Both since both these sides are equivalent. So no matter whichever we will write in whatever fashion here. So the product form will be a the cobalt will be here. So we'll try to this one. So this one won't attack here. This nitrogen will attack here. So the product will be like this. So right, and here CH2 CO2 ET, and the cobalt will be at this upside, right? So this cobalt will be upside, and which will be further get eliminated in the next step. Here double bond I forgot, because when it attack here, see double bond get migrated here, and it attack through this carbon atom, and the from product will be a containing this one. Here will be double bond, and it will be get aromatized. See, uh, this bond goes to here, the bond goes to here, and this will be get eliminated. So we can see here. It's not over. So this one is the product. Right. So the product will be this one. So we can see which option is the correct one. So CH2 COET. Yeah, this option given, and here they have given the see here CH2 ET are directly attached to this one, and if you see the position of this CN, this is wrong one, incorrect. So the option A is the correct answer. So we can see I have given here mechanism. You can have a look here. Right. So this one is the product. So Option A is the correct option. Remaining option is incorrect. Always remember this ammonical cupric nitrate. This one test qualitative test for alkyne. When alkyne reacted with this solution, it forms a red precipitate. So this definitely give a red precipitate since this dialkyne. So it will give a red precipitate. And upon this reaction with this uh, cobalt complex and this cyanide, so it forms a this product B. Next question, identify A, B, C in the following reaction sequence. So I will just check whether recording is going on. Yeah, because last time what happened, I have completed all session and then I have not recorded video. So I am repeating this recording for recording only. Here, the question given, identify ABC in the following reaction. So first, they have given this, if you see alpha beta unsaturated ketone, right? And it converted to epoxide. So this is question based on the our reagent and reduce selectivity of this attack of the reagent. So MCPBA, we know the MCPBA, when the MCPBA in this case, in two options they have given MCPBA and two options they have given H2O2 NaOH. So you know MCPBA when reacted with the alpha beta unsaturated it form the epoxides. So when MCPBA will react here, it form epoxide, but there is one possibility. When the ketone is present, then it probably reacted with the ketone only and it form a ester compound, right? So this one will be a incorrect option. H2O2 form this epoxide when reacted with the alkene. And this one, since it's tertiary alkene, so it form epoxide. And then when this epoxide TSNH2 ETOH, ethanol, this is the example of the, in this one, what is getting formed here when TSNH2 is here. So this TSNH2 forms a, this IPR will be here. The bond between these will be getting cleaved, right? Because it's a base and here, sorry, yeah, I'll draw a mechanism for this one because it's little complex mechanism. In the, I'll add here, I'll draw here structure first. So we'll draw a mechanism. Right. When this phase is reacted with the H2O2, it form a, right. So it form a epoxide, right here. And when it reacted with this NH2 NH NH NH2 NH2, right? So this one is the example of Ilchmer Tanabe fragmentation reaction, right? So in this one, what is get the in place of this pyridine, what is getting formed? This initially form a imine with this one. So the form imine will be like this, N NH-TS, right? So this one will be formed, and this pyridine The pyridine abstract a proton from this here. Pyridine abstract a proton. So this bond getting shifted here and this bond will be here. So here will be a double bond, here will N TS, right? And this O will be get opened. So here will be O negative. Then after this one, this O negative form will uh, go back to here, and this bond shifted to this one, and this entire species get lived. So after this one, what you are getting from? So this one is the IPR acid. So here methyl group will be here. This will form a ketone, right? And this entire remaining fragment will be uh, as it is, but at the end terminal side, at this position you can see here alkyne is getting formed. So here N2TS will be getting eliminated, and here will become alkyne. So this species is getting formed in this one. So B species will be this one. This one will be a B species. Now this B species when reacted with the, we'll add one more slide. So we'll draw B species here. Right. So this one is the species, right? And what they have given? When this species reacted with the Br2NaOH and then HgCF3CO2 complex, then it formed when it reacted with the bromine. So the bromination, the mechanism will be for this bromination. Bromoform, right? We can see here reagent Br2NaOH, right? Br2NaOH, we know Br2 in NaOH. This is the bromoform test, right? So what will getting from here will be this IPR group will be like this. Since this carbon will convert into CPR3 because it's not bromination reaction. The bromine and NaOH, this one is the bromoform test. So this product is getting formed. And now NaOH, what NaOH can do? This NaOH will attack here at this carbonyl center, right? And CBr4 will be get eliminated. CBr3 will be get eliminated. So form product will be like this. Its OH will be here. This one will be a product. And then again, what another next condition? Hg, CF3, this reaction. This is the Hg catalyzed alkyne hydrolysis, right? So this Hg will attack here, right? So it form a chelate here, and this alkyne is getting form a complex, this Hg plus complex with this alkyne, this IPR group here, double bond O, here OH, right? So this OH bond help to cleave this bond. So here at this side it will be get open, and the form product will be this one will be get removed, and after H plus, this Hg also get eliminated, right? So Hg will be this bond go with there, and he will be here. So this negative charge abstract a proton. So the final product will be look like this one. So this one is the C. So we can see in options. So we have seen the S2NOH. S2NOH will be the good best condition for this conversion. And after that, when it reacted with this TSNH2 ETOH, then it forms a alkyne. Here we can say which alkyne is getting formed here. So this alkyne is getting formed. So here the position of IPR group should be here, right? As we have seen here. So this alkyne group is just adjacent to this methyl group. So here, this one. In this B, the alkyne group, the isopropyl group is just adjacent to this ketone. So in this option, this one is the correct one, and last product form product will be like this. So this one is the last product, right? C. So here, this one is the correct option. So D option is the correct option. So we'll see a next question. So I will look. So the next question is identify A and B of the following reaction sequence. So they have given some reagent, starting material, and this cobalt complex added one equivalent. It forms A, and then again this treated with the MeSO2Cl in presence of triethylamine and DCM refluxed, followed by ferric ammonium nitrate and methanol at 0°C. It forms a B. So you need to identify which are these product getting formed in the sequence of this this reaction sequence. So we'll solve this one by using by drawing a reaction mechanism. So here uh, I have solved this one. So you can see here when this cobalt complex, this 18 electron complex reacted with this molecule, it loses a 2CO and to form a this terminal alkyne get coordinated with this metal center, right? With this alkyne bond, So this pH will be here, which to the carbon directly attached to this one. So this one is be A because this one is an intermolecular Nicolas reaction. This alkyne reacted with this cobalt complex, and it form a 18 electron complex. This, so which further reacted with the MeSO2Cl in presence of triethylamine. So what's getting happen? This OH reacted. This have the lone pair of electron, right? So it reacted with the S double bond O, Cl and ethyl. This reacted with this sulfur and this chloride get removed. So it form this intermediate, and again when it refluxed, at this reflux condition, this bond is getting migrated to this carbon, and this O3S Me species is getting MESO3 minus getting eliminated, and it form a ring containing this oxygen atom because this attack through this oxygen. And see, this bond is getting close, so here will be a positive charge. This positive charge get this pyrolytic elimination type reaction. So this form an alkyne alpha beta for elimination of beta SiMe3 group, So it form alkyne, and still up to here this cobalt complex is getting intact. When it reacted with this steric ammonium nitrate, it again this alkyne is reappear, and here you can see this cobalt complex it's converted into the converted into alkyne product B. So this is the reaction mechanism. So the option among this one option we can select the A product will be this electrolyte electron complex, this one A, and this product will be this one. So the option we can just match which option is the correct option. So here you can see the option B is the correct option, right? So this one is the correct option. So next question, predict the product when the following bis propargyl sulfone P. Bis propargyl sulfone is made undergo Garrett Bewerman cyclization in presence of a base. So we'll see the reaction mechanism of this reaction. When this reaction Garrett Bewerman cyclization reaction base, in this reaction base will be the N, it is the triethylamine. When this created the triethylamine, what's getting happened? This because it abstracts the proton right here from here. So this proton is getting abstract. So this proton after abstraction, this bond will be formed, and like this product will be formed here. So here, here the this type of radical mechanism will getting followed, and it form a S double bond, double bond. Here will be a radical, right? And here the radical be here. So this one is getting formed, and again with the next in the next step, this radical migration will be takes place. This radical will go here, and it attack here with the through this radical center, right? And the product will be so here will be a 6-member ring, right? And here will be a methyl and hydrogen. So this one will be a product here, and after this, what will be happen? So here also you can see here will be two hydrogens. So this hydrogen get right. This one will be migrated like this, and second in the another side also. So this hydrogen will migrated here. So I will just draw a little small. You can see here this hydrogen migrate here. So double bond migration will take place, and this the form product will be this 6-member ring, right? In this one you can see this one here. Right. So this aromatic, this ring will gain aromaticity, and this sulfur will be double bond, double bond. Right. So this one will be the product. So we'll match here, which is the product, and this methyl one. So methyl one check here is at the this adjacent carbon, this methyl. So the carbon which is adjacent to this 5-member ring. So here the D is the sorry not D. Here we can see this SO2. Here it should be a opposite. So this will be obviously these two are obvious wrong answers. We need to compare in these two. And here, this methyl should be adjacent carbon, right? Or to this 5-member ring, the methyl should be adjacent. So this one B is the correct option. So this one is a simple example of Garrett-Bremner cyclation reaction. So here mechanism I have given. The next question is, select the correct pair of starting materials for the cyclopentanone P and Q in presence of CO2 CO8 as a catalyst using Paschen-Kund reaction. So the Paschen-Kund reaction given, and we need to identify the correct pair of starting material for cycle these two. So P and Q. For P and for Q, which are the starting material. So the in Paschen-Kund reaction, the reactant will be a carbon monoxide as well as the alkyne and one alkene. So starting materials are alkyne, alkene, and a carbon monoxide. These are the starting materials. So we can imaginary draw where will be for this one. If you see this, so what will be the alkyne for this one? So see, this one will be a carbonyl compound, right? And this part will belong to alkyne, alkene, sorry, and this part will belong to alkyne. So imaginary will draw structure. So this one obviously intramolecular alkene and alkyne will be in this one. So here oxygen, carbon, this carbon will be like this 1, 2, 3. This part belong to alkene, right? So 3, 1, 2, 3. This part belong to alkene. And here this one will be a carbon carbon, so no need to draw here. And remaining you can see. So here this one A, B, and C. This A, B, and C, this belong to alkyne, sorry. And here R2. So this one will be a starting materials for formation of this P in the Paschen-Kund reaction. So here it is. Here we can see intramolecular alkene. This one is obviously a wrong option. So we have already seen here. This one is the intramolecular alkene plus alkyne. In the same molecule, alkene and alkyne are present. So this one is a wrong one. This one is also a wrong. In these two, we need to compare. So here see R2 they have given, as well as here the alkyne given. Here no need to worry about the cis and trans alkyne. So here these two alkyne, both the alkyne they are given same. But here we can check the R1 should be at the side of alkene, right? Double bonded side. So here R2 they have given. So R2 here it is in the side of alkene, right? Here, sorry, in the side of alkyne. So this one is the wrong one. So this option C is the correct option. In this one only we can able to uh, check which is correct one. Now we'll see. Although there is no need to go further, but just for cross checking, we can check here. So here also we can check. So this carbonyl carbon we can separate from this one like this, and see this double bond will be in this one. So obviously this part is belong to alkene side, right? Here also we can see up to here only it belong, and here this part belong to alkene side. So this alkyne plus this carbonyl, right? And plus, sorry, this type of alkene. So these are the starting material for this Q. So Q, right, acetylene is the correct one. Acetylene plus this, sorry, I have written here 3 bonds, right? Double bond will be here. So this one will be the correct one. And carbon monoxide, obviously the carbon monoxide will be a starting material. So for Q, so this one is the correct set of the starting materials, and for P, this one will be a correct set of starting material. Here we can see the position of R2 and R1. They have interchange, so don't be confused here. So it looks although same, but if you compare R1 and R2 here, they have given R2. So R2 should be at the side of here, if you see, and R2 should be at the side of this the alkyne side, right? So the option C is the correct option. So here you can check the complete mechanism. So no need to go for the such MCQ type entire mechanism. We can just by seeing the product, uh, we can think of the starting, which are the starting material for this one. The next question is predict the major product M form in the Bellmuth cyclation and form as a product of Garrett-Brauman cyclation reaction when these reactions are carried out in presence of 1,4-cyclohexadiene, right? So they are given 1,4-cyclohexadiene. So this one on heating. So after heating, we'll draw directly a reaction mechanism so as we can get up to a product. So this one, when it heated this cyclohexadiene, these two, when this starting is heated, right? So we'll see here. After heating, what happened? This form a reaction and the radical at this position, right? R1 and R2, and this radical treated with the D4, 1,4-cyclohexadiene D4. So when it treated with this molecule, then the deuterium will be exchanged. So deuterium will be attached here, this one. So this one will be a product one for this reaction. So M will be here like this, right? So the M will be, you can see the deuterium at the here will be deuterium, here will be deuterium, and R1 and R2 like this. So we can see this one is the correct one. These are the wrong. So in between C and D we need to compare. So in this one, what is the product in this one? So when it reacted with the triethylamine, I will just there's something happen with this writing pad. Oh, yes. So I will just stop sharing and again. So there is issue with this PowerPoint presentation. PowerPoint. Oh, so all right, we can see here. Just focus on the blue one. Forget about this red part. So this triethylamine reacted to form the intermediate like this. This already we have also seen the example of this one. So this one is getting formed, and this intramolecular cyclization type reaction by through the radical mechanism, it form an intermediate, and which this intermediate is on the rearrangement of this here we can see here the radical migrate here, and this form a bond through this carbon which from this benzene ring, right? So this bond is newly formed bond will be here or here, and hydrogen elimination, that is 1,3 hydrogen ship and 1,5 hydrogen ship to give rise to this N product, the product N. So this one is the product one. So which is correct option here? This N will be like this or like this. So we can see the N will be this, which containing the benzene ring, this sorry phenyl ring here. So not this one. It should contain the phenyl ring. So the option D is the correct option. So this one is the wrong one. Option D, the correct option. Correct option. So in this way, we have solved some questions from the week uh, fifth material topics which are covered by professor. So hope uh, you are able to solve the assignment problems uh, by using these by comparing the assignment problem with these solved questions. So thank you very much for joining. I will stop sharing here, and you please ask whichever question you want to, uh, whichever doubt from this week 5 topics.